Assessment of progressive collapse of G+7 RC building. A simplified framework is proposed for progressive collapse assessment of multi-story buildings, considering sudden column loss as a design scenario. This framework can be applied at various levels of structural idealization, and enables the quantification of structural robustness taking into account the combined influences of redundancy, ductility, and energy absorption. This study aims to provide the designer engineers with wider overview on this topic to minimize the consequences of buildings' progressive collapse after the event of column removal scenario. A 7-story reinforced concrete framed structure is considered in the study to evaluate the demand capacity ratio, D.C.R, the ratio of the member force and the member strength as per U.S. General Services Administration, GSA, guidelines. The nonlinear static analysis is carried out using software, STAAD PRO according to Indian standard codes. To study the collapse, typical columns are removed one at a time, and continued with analysis and design. Many such columns are removed in different trials to know the effects of progressive analysis. Member forces and reinforcement details are calculated. From the analysis, D.C.R values of beams are calculated. Keywords: RC building, progressive collapse, nonlinear static analysis. Introduction. Progressive collapse is a situation where local failure of a primary structural component leads to the collapse of adjoining members which, in turn, leads to additional collapse. Hence, the total damage is disproportionate to the original cause. Progressive collapse: the spread of local damage, from an initiating event, from element to element resulting, eventually, in the collapse of an entire structure or a disproportionately large part of it, also known as disproportionate collapse. This failure occurs when a building loses one or more of its vertical load-carrying components. This loss could be the result of an unexpected loading, like a vehicle accident, an explosion, terroristic attack, or a construction/design error. The single element failure can lead to a larger damage in determinate structure, for that this structural system is not robust. In contrast to indeterminate structure, the collapse of one element will not cause building failure as other element can compensate the local damage and bridge out the load of damaged element to undamaged near elements. Structural robustness is a function of structural degree of redundancy, which represents the structure ability to redistribute loads after collapse to intact members. Aim and objective. To analyze, design G+7 RC structure by using different measures to sustain progressive collapse. To perform analysis for the proposed structure with removal of critical columns fully to no potential for progressive collapse. The objective of dissertation includes: to analyze, design G+7 RC structure by using different measures to sustain progressive collapse. To perform analysis for the proposed structure with removal of critical columns fully to no potential for progressive collapse. To suggest effective method for design of new building to avoid progressive collapse. Overview of progressive collapse. A general. All different guidelines identify 3 basic design methods for progressive collapse prevention: event control, direct design approach and indirect design approach. The 3 methods are explained as follows. A. Event control, protection and isolation of the building from any accident loads that can cause progressive collapse. B. Direct design approach, focuses on providing building with resisting mechanisms, one alternate path method by improving the structure ability to transfer the loads of the damaged elements to intact regions through 2 mechanisms, via radial and catenary/membrane action. 2 specific local resistance, SLR, method, which focuses on providing sufficient strength to the key elements in the building to withstand these abnormal loads. C. Indirect design approach. This approach aims to guarantee the minimum level of strength, continuity, and ductility for different buildings elements depending on selecting suitable plan layout, horizontal and vertical tie systems, and seismic ductile detailing. For that, indirect design method is the first line of defense towards catastrophic failures. Methodology. Building configuration. To study the effect of column removal condition on the structure, 7-story building is considered. Progressive collapse analysis is based on the GSA guidelines. Structure considered in this analysis is hospital building, which is designed for an importance factor 1.5, is code 1893-2016. Figure shows typical floor plan. B. Analysis. To evaluate the potential for progressive collapse of a 7-story reinforced concrete building using the nonlinear static analysis, column removal conditions is considered. First, building is designed in STAAD PRO for the IS 1893, Part I, load combinations. Demand capacity ratio for the moments and forces at all stories is calculated for each cases of column failure. Capacity of the member at any section is calculated as per IS 456:2000 from the obtained reinforcement details after analysis and design. Member forces are obtained by analysis results carried out in STAAD PRO. After analysis and design of the building by using above mentioned options, nonlinear analysis will be carried out to check effectiveness of options against progressive collapse. After studying various literature survey, it seems that corner column removal is quite critical case, so worked on only corner. For result and discussion. A. General. 5 building models of 7-story are generated using software STAAD PRO. Each models of 7-story are analyzed for corner column removal case. The progressive collapse analysis is done according to the GSA guidelines. Linear static analysis has been carried out. Comparison of all cases is done on the basis of demand capacity ratio. Obtained results have been presented in form of graphs/charts, indicating the trends and pattern of demand capacity ratio. 4 different mitigation approaches like providing bracing at bottom and top floors, by considering beam above column removal to be designed as cantilever beam, by considering load combination as suggested by GSA and by increasing column and beam sizes by 20% at column removal location. B. Render view for different cases with 4 mitigation provided. With corner column removal. Render view showing corner column removal case, front view. Render view showing corner column removal case, back view. Shows the 100% corner column removal, i.e. all corner column are removed at a time for considering the critical case. Providing inverted V-type bracing at ground and roof floor level. Render view showing bracing member provided as ground and roof floor level. By considering beam above column removal to be designed as cantilever beam. By considering load combination as suggested by GSA. Load combination as per GSA included in STAAD analysis. D. Flexural demand for various cases. Obtained results have been presented in form of graphs, charts, and tables indicating the trends and pattern of D.C.R ratio in flexure. Conclusion. A progressive collapse analysis of building. The analytical study on both 7-story building is done by creating the 3D model, and the analysis is done for all corner column removal cases by following GSA guidelines. Progressive collapse potential of building is found out by considering column removal cases. Demand capacity ratio in flexure is calculated for all the cases. From the study, the following conclusions can be drawn out. 1. D.C.R in flexure of beam exceeds permissible limit of 2.0 in all story of for case 3, 4 and 5. The D.C.R values in beams in case 2i.e. by providing inverted V-type bracing at ground and roof floor level are within limit, indicate that building considered for the study is having very low potential to resist the progressive collapse when column is considered as fully damaged/removed. The adjacent beam to the damaged/removed column joint experienced more damage as compared to the beams which are away from the removed column joint. Corner column case is found critical in the event of progressive collapse. The beams adjacent to the damaged/removed column joint experienced more damage as compared to the beams which are away from the removed column joint. 4 different alternatives are used to mitigate the progressive collapse. When mitigation alternatives are adopted, D.C.R value is reduced within permissible limit. From 4 mitigation alternatives presented, provision of bracing in the building is economical solution to reduce the potential of progressive collapse. Scope of future work. There is a scope of extending this work to include the following for future. The present work has been carried out to calculate the D.C.R for a symmetric building. The work can be extended to asymmetric buildings. In this study STAAD PRO has been used. Other software like SAP, and ANSI etc. can be used. Here linear static and linear dynamic, response spectrum method, analysis have been performed. Pushover nonlinear analysis can be done for same building.